GIS.fcu implemented two deliverables in this pilot: Sensorthings and WFS server. The Sensorthings API server provided the air synthetic data, which is the real PM2.5 data from Seifu IoT Taiwan Data Service Platform. We've collected the data from 19 stations in the air quality station dataset, and it is imported to the database. All coordinates of the locations are moved to Sejong City. The listed data entities are implemented, including scenes, locations, historical locations, data streams, sensors, observed properties, observations, and features of interest. Moreover, defining the relationship between the sensors and their corresponding GML is one of the main purposes in this pilot. In order to connect with the City GML building, property GML ID is put in the properties of things, and property array associations links to the related city building features. For example, the thing object on the screen shows a sensor station associated with a feature from GIS.fcu web feature service, which is a building in Sejong City. Since we've got the GML ID from Sensorthings API, we can query more building information by the getFeature or getFeatures request to the WFS server. The implementation of GIS.fcu web feature service follows the OGC API features version 1.0 standard. In the outdoor scenario, the client can send a getFeature or getFeatures request with a bounding box or the GML ID of the building to query building features of Sejong City. The API services will return the GeoJSON encoding building features. Since the support for 3D models is out of scope of GeoJSON in OGC API features, we added the GLTF model URL as property of building features. So after receive the GeoJSON response, the client can also download 3D models directly by parsing the property model URL of the features in the response GeoJSON. For example of a getFeature request with bounding box, the received GeoJSON response on the right side of the screen is directly shown on the map with geojson.io. Then, the client can download 3D models by parsing the property model URL. After parsing all the model URL, the client could download GLTF models and visualize them in the GLTF supported client. By associating these two services, real-world sensor data and real-world feature information can be connected together for integrating environmental, building, real-time Internet of Things data in smart cities.